we will discuss various scenarios of analytical epidemiology. How will you identify case control study and cohort study? What are various points of identification of these studies? We will also discuss differences between them. So, we will do this session according to following learning objectives. First, we will discuss the difference between case control study and cohort study, and then we'll solve certain numericals of case control study and cohort study. In the end, we'll summarize the session. Let's start. What are major differences between case control study and cohort study? Case control study is a retrospective study, and cohort study is a prospective study. It means that in case control study, we move from outcome to exposure, and in cohort study, we move from exposure to outcome. Then, case control study starts with the disease. The participants, the cases who are included in case control study are diseased people, while in cohort study, they all are exposed but they are not diseased. Exposure is necessary in cohort study, but we'll follow up them and see how many develop the disease. But in case control study, we took diseased people, moved to past, and see how many of them were exposed. Then it tests. In case control study, we see that the suspected cause is more frequent in diseased or in without diseased people. Like we see that smoking causes lung cancer. We took people who are having lung cancer and we move to past and see the people who are diseased, who are smokers or not. And in cohort study, we move forward. We took smokers, we follow up them and see after the follow up that how many of them develop the disease. Then case control study involves fewer subjects. A less number of people are required to conduct case control study. This means it can lead to bias or error. And in cohort study, we need large number of people because when we do follow up, many of them will leave, many of them will migrate. So there is attrition problem in cohort study. What is meant by attrition? Attrition means loss of follow-up. That's why we need to take a larger sample in cohort study. This may be the diagnostic point of cohort study. We take thousands. We take the sample in thousands and we monitor the sample for 10 years, for 20 years, and see how many of them develop the disease. And in the end, let's see, for example, we took a sample of 10,000 and we need a follow up for 10 years. Most likely, half of them will leave because people may migrate, they may die. So, we need to consider this point before conducting a cohort study. And case control study is the first approach of testing hypotheses. We need to see a hypothesis. Or we can say that for certain cancers, we need to conduct a case control study. And cohort study, we need a precise hypothesis. Like we need to know that this exposure leads this outcome, or this exposure can cause this disease, or we can say that exposure to smoking, exposure to alcohol can lead to esophageal carcinoma. We need an evidence. Or we can say that obese people can develop ischemic heart disease. As you know that case control study generates quick results because it's a retrospective study. We need to move in past. We have cases, but for hard study, follow up and time period is required. It takes time, take longer period of time. And case control study is suitable for rare diseases like cancers. But cohort study is inappropriate for rare diseases. Case control study only estimates relative risk. It can't measure relative risk precisely because we can't measure incidence in case control study. So it usually measures odds ratio. Odds ratio is strength of association in case control study. And in cohort study, we can measure incidence. When we can measure incidence, we can measure relative risk. Relative risk is a ratio between those who are exposed and those who are not exposed. And we can also measure attributable risk, specificity, like our risk factor is responsible for our risk factor is responsible for the disease or it is specific for the disease. So we can measure three things from cohort study. Incidence. After measuring incidence, we can measure relative risk. After measuring relative risk, we can measure attributable risk. This is a common university question. Measurement of risk in case control study is odds ratio. Measurement of risk in cohort study is relative risk and attributable risk. But we need to measure incidence before the calculation of relative risk. So, case control study yields information regarding one disease, but cohort study can yield information regarding other diseases, regarding more than one disease cause. In case control study, we took the cases. In cohort study, we move from exposure to outcome. So this exposure may lead to other outcomes. And then case control study is cheaper, it is inexpensive, while cohort study is expensive. Cost, time process, it takes time. So these are the major differences between case control study and cohort study. You have to remember few things, that one is retrospective, other is prospective. One is expensive, other is inexpensive. One can measure odds ratio, other can measure incidence, relative risk, and attributable risk. So now we will do a exercise, or we will solve numericals regarding case control study and cohort study. You have to remember few things, like in the given scenario, the number of patients with cervical cancer is increasing. Yeah, patients with cervical cancer are increasing day by day, and scientists think that it is associated with the use of oral contraceptives, or people who are using oral contraceptives have greater risk of developing cervical cancer. So we conducted a study and enrolled 70 female who were using OCPs and 85 women who were not using OCPs. So this is exposure. And after 5 years of continuous monitoring, we found that 14 OCP users and 2 non-OCP users developed cervical cancer. So this is cohort study. How? In cohort study, we move from exposure to outcome. This means that number of exposed people is greater than those who are diseased. In this scenario, exposed people were 70 and diseased people are 14. Or we can say that number of exposed and number of non-exposed people is greater than those who have the disease. So remember this point. 70 people are exposed or 70 women are exposed, but only 14 develop the disease. So this is cohort study. Plus there is another hint after 5 years of continuous monitoring. So how we will solve this scenario? So first we have to make 2 by 2 table. We draw and label 2 by 2 table, like we write disease here and non-diseased here. These are exposed and these are non-exposed. So we see that 70 women were exposed. They were using OCPs, while 85 women were non-exposed. They were not using any OCP. Now we'll move in this direction. We'll move from exposure to outcome. Out of 70, 14 developed cervical cancer. So 56 did not develop the disease. Total number of exposed people was 70. If 14 developed, Disease. How many of them were non-diseased? We subtract disease from total. So our answer will be 56. 56 don't develop. And among 85 who are not using OCPs, only 2 develop the disease. So we write 2 here and we subtract disease from total population of non-OCP users. Our answer will be 83. So we write 83 here. In this way, we'll construct 2 by 2 table. You must remember, these are exposed, these are non-exposed. You have to divide exposure into disease and non-disease. You have to divide non-exposure into disease and non-disease, like exposure in cohort study. We divide exposure into diseased and non-diseased. And we'll divide non-exposed into diseased and non-diseased. So number of exposed and number of non-exposed people will be greater than diseased. Okay. We will calculate incidence, relative risk. How we will calculate? Now we will calculate the incidence. We will calculate incidence among exposed and incidence among non-exposed. So first we will calculate incidence among exposed. 70 people were exposed. Among them, only 14 developed the disease. So we divide 14 who developed the disease with total number of exposed people and multiply it with 1000. Or we can write formula. 14 is A. You can see these all are exposed. 70 were exposed, 14 developed the disease. So we divide A into A plus B and multiply it by 1000. So what will be our answer? Our answer will be 200 per 1000. This means that among 1000 people, 200 develop cervical cancer. So now we will measure incidence on non-exposed. We see that 85 women were non-exposed and they were not using OCPs. 2 of them developed cervical cancer. So we divide 2 with 85, total number of non-exposed women. Or we can say that we divide C with C plus T cause these 2 developed cervical cancer among 85. So if we calculate this, we have to divide 2000 from 85. Our answer will be roughly 23 per 1000. So incidence is greater in women who are using OCPs. So we can say that there is association between cervical cancer and use of OCPs. Now we have to see whether this association is strong enough or not. Now we will measure the strength of association. How will measure the strength of association? We can measure the strength of association by calculating relative risk. What is relative risk? It is the difference between incidence among exposed and incidence among non-exposed. We see that incidence of exposed is 200, incidence of non-exposed is 23. So we divide them and our answer should be 8 per 8. Roughly, our answer will be 8. What do you mean by 8? We have to interpret it. It means that women who are using OCPs have 8 times greater risk of developing cervical cancer as compared with those who are not using OCPs. So there is strength of association. If relative risk is greater than 1, it is positive association. So we have positive association. If relative risk is 1, there is no association. If it is lesser than 1, there is negative association. Now, we will measure attributable risk. What is attributable risk? It measures specificity. While calculating attributable risk, we subtract incidence of exposed from incidence among non-exposed and divide them with incidence of exposed and multiply it with 100. What will be our answer? If we subtract 200 by 23, 177 divided by 200. We can use calculators. Calculators are allowed. Remember this thing. They are allowed in examination. So there is no need to worry regarding these calculations. You must know the formula. You must know how to calculate them. So our answer will be roughly 88%. This means that in our study, 88% of cervical cancer in women is due to OCP. So it is greater than 0. So it is positive association. 88% of cervical cancer is caused by OCPs in women who are included in our study. So we can conclude that incidence among exposed female is greater. So there is an association. Relative risk is greater than 1, so it is positive association. Attributable risk is greater than 0, it is positive association. Now we'll move forward. Then a researcher conducted a study to see the relationship between alcohol intake and liver cirrhosis. He took 70 cases of liver cirrhosis and 50, out of which 50 use alcohol regularly. Out of 50 controls, only 10 use alcohol. What is this study? This is very easy scenario. He has already given that there were 70 cases of liver cirrhosis and 50 were using alcohol. So number of diseased people is greater than exposed. Alcohol is exposure. Liver cirrhosis is disease. So this is case control study. And then we will calculate the association. So first we will draw 2 by 2 table. We can write case in case control study instead of diseased. These are controls. Then these are exposed. These are non-exposed. So there were 70 cases of liver cirrhosis and 50 controls. So we can write 70 cases and 50 controls. Remember one thing, we have to move in upward direction or downward direction in case control study because we divide the case into exposed and non-exposed. Number of cases is greater than people who are exposed. Among 70, 50 use alcohol. So 50 were exposed and 20 were non-exposed. How? We subtract 70 with exposed. We'll get those who are non-exposed. So 50 plus 20 is 70. And 10 who are controls, who are not having the disease, were alcoholists. So we subtract 10 from 50 and we'll get non-exposed people. It is 40. So we see that 10 plus 40, 50 controls, 50 plus 20, 70 cases. So we will measure exposure rate in case control study. Exposure rate in case and controls. First we will measure exposure rate in case. How many cases were exposed? These are total number of cases. So we can write the formula A over A plus C into 100. A are those who were exposed. 50 were exposed and there were total 70 cases. So we will calculate them. It is roughly 71%. It means that exposure rate in cases is 71%. Now we'll measure exposure rate in controls. There are 50 controls and only 10 were exposed. So we can write the formula B divided by P plus D into 100. 10 were exposed out of 50. Is equal to 20%. So exposure rate in case is greater than in control. So we can say that there is some association between risk factor and disease. But now we will measure odds ratio to see the strength of association. So we will calculate odds ratio. Odds ratio shows the strength of association in case control study. So how will you calculate odds ratio? Formula is AD over BC. So we will multiply A with D. We'll multiply exposed people of cases with non-exposed people of control and divide it with exposed controls with non-exposed cases. Or you can simply remember the formula AD over BC. We take a chance. This is indirect measure of risk because in case control study, we can't measure the risk directly. So we'll find odds ratio, which is indirect measure of risk. So remember the cross. AD over BC. How will you calculate? We'll multiply 50 with 40 and 10 with 20. So A is 50, D is 40, and B is 10, and C is 20. So if you multiply 50 with 40, the answer is 2000. If we multiply 10 with 20, the answer will be 200. So odds ratio is 10. Now, how will we interpret? We can say that people who are exposed have 10 times greater risk of developing the disease as compared with those who are non-exposed. So, in our study, there is strength of association. Risk factor is associated with disease. So we can say that odds ratio is 10. So exposed have 10 times greater risk of developing the disease. So remember, we'll measure exposure rate in case control study and odds ratio. It's a common university question. They will ask, how will you measure the risk in case control study? You will measure odds ratio in case control study. And then move to next. In a study, history of smoking was taken to investigate the association of smoking with oral cancers. So we have the hypothesis that smoking causes oral cancers. So we took 650 people with oral cancer and 90 normal or non-disease people. Among 675 people who have oral cancers, only 14 were smokers. And among non-disease people, 3 were smokers. Identify the study design. This is case control study. Oh, this is case control study. Number of disease people is greater than exposed people. Okay. Now we'll solve this scenario. First, we'll draw 2 by 2 table. We can write case, control, exposed, non-exposed. We fill the boxes A, B, C, D. in the scenario. 66, 75 people were diseased and 90 were non-diseased. 14 were smokers among diseased and 90 non-disease participants, 3 were non-smokers. 14 were smokers. And in controls, 3 were non-smokers. So you have to read the scenario carefully. Examiner has tried to create a confusion by giving 3 were non-smoker. Most of the students studied smokers. So you have to read the scenario carefully, subdivide the scenario, and then draw the table. Then you will solve it. Among diseased, 14 were smokers. So we'll subtract 75 with 14. Our answer will be 661. 661 were non-smokers. And among non-diseased, only 3 were non-smokers. So we need to subtract 3 from 90. Our answer will be 87. 87 non-diseased people were smokers. So now we will calculate exposure rate of case and control. What is exposure rate of case? These are the cases. 14 cases were exposed out of 675 cases. So roughly our answer will be 20%. Exposure rate in case is 20%. Now we will calculate exposure rate in controls. These are the controls. 87 controls were exposed out of 90. Our answer will be roughly 90%. Exposure rate is control is greater than exposure rate in cases. So there is no association between risk factor and disease. Or we can say there is negative association. Now we will calculate odds ratio. Remember the formula AD over BC. What is A? 14 and D is 3. So we'll multiply 14 with 3. 14 multiplied by 3. And B is 87 and C is 661. We'll multiply 87 with 661. What will be our answer? So we'll calculate odds ratio. Odds ratio is 0.0073. It is lesser than 1. So there is negative association. Or we can say that there is no association of smoking and oral cancers in our study. These type of scenarios can be given in university because you have to interpret the results. We will interpret the results on the basis of exposure rate and on the basis of odds ratio. If it is lesser than 1, there is negative association. Now, a case control study was conducted. They have already given, this is a case control study, that obesity is a risk factor for hypertension. 40 hypertensive and 50 non-hypertensive were inducted in the study. They collected the data. Hypertensive, 18, and among normotensive, 11 were obese. So we have to construct a 2 by 2 table and we have to measure the risk, interpret our results. So first, we will construct 2 by 2 table in this study. We have to subdivide the scenario accordingly. Like we can write case and we can write control here. These are exposed and these are non-exposed. So this study said that 40 hypertensive and 51 normotensive. 40 hypertensive and 51 normotensive. Yeah, normal. Or we can say that these are normal. So among 40 hypertensives, 18 were obese. 18 were exposed, and among normotensives, 11 were exposed. So we'll write 40 cases, 51 controls. 18 were obese or 18 were exposed. So we'll subtract 18 with 40. Our answer is 22. So 22 cases were non-exposed. And there were 51 normotensive. 11 were obese. So we'll subtract 11 with 51. Our answer will be 40. 40 normotensives were non-exposed and 11 normotensives were exposed. Now we will calculate exposure rate of case and exposure rate of control, and we'll compare them. So first we'll calculate exposure rate of case. There were total 40 cases and 18 were exposed. So we'll divide 18 with 40 and multiply it with 100. Will be our answer. Answer will be 45%. This means that 45% of cases are exposed or 45% hypertensive or obese in our study. What is exposure rate of control? 11 controls were exposed out of 51. So we'll divide 11 with 51 and multiply it with 100. Our answer will be 20%. Our estimated answer will be 20%. So exposure rate in case is greater than exposure rate is in control. So there is an association between risk factor and disease, or we can say that there is association of obesity and hypertension. Now we will calculate odds ratio. Our odds ratio is measured AD over BC. What is A and what is D? A is 18 and D is 40. So we will multiply 18 with 40. What is B? We multiply 11 with 22. Our answer will be 8.1. Now we will interpret that those who are exposed have 8.11 times greater risk of developing the disease. In our scenario, we can say that obese people have 8.1 times greater risk of developing hypertension than non-obese. So obesity is a risk factor for development of hypertension. This study gives a clue. Now we will intervene. Now we will try to reduce the obesity or try to control weight. We will target obese people. We'll modify their lifestyle. We'll change their lifestyle. We'll change their dietary habits. So we'll reduce the incidence of obesity and then we can reduce the incidence of hypertension. Now, in a hypothetical cohort study, they have given this is cohort study, association between smoking and coronary heart disease. There is association between smoking and coronary heart disease. They took 300 smokers and 500 non-smokers. 84 smokers developed coronary heart disease and 87 non-smokers developed the disease. So we'll draw a 2 by 2 table. We'll draw in the same way. We can write diseased and non-diseased. These are exposed and these are non-exposed. They have told that there were 3,000 smokers, means exposed people are 3,000 and 5,000 were non-smokers. Fill the table. In the scenario, it is given that 84 smokers develop the disease and 87 non-smokers develop the disease. So we'll write 84 here and 87 here. There were 3,000 total smokers. 84 developed disease, so our answer will be 2,916. 2,916 smoker did not develop the disease. Out of 5,000 non-smokers, 87 developed the disease. So 4,913, 4,913 non-smokers did not develop the disease. So we have drawn 2 by 2 table. If we calculate A plus B, answer is 3,000. If we calculate C plus D, answer is 5,000. Now we will measure the incidence among exposed and incidence among non-exposed. So we'll calculate incidence. First, we'll calculate incidence among exposed. 3,000 people were exposed or 3,000 were smokers. 84 developed the disease. We'll multiply it with 1,000. Always remember, multiplier of incidence is 1,000. Answer will be 28 per 1,000. This means that 28 per 1,000 smoker develop the disease. What is the incidence among non-exposed? 5,000 people were non-exposed and 87 developed the disease. We will calculate it. Roughly it is 17 per 1,000. So incidence among exposed is greater than incidence among non-exposed. So we can say that there is association. We can say that in our scenario, there is association of smoking and coronary heart disease, or there is an association between smoking and heart disease. Smoking can lead to heart disease. So we can get a clue. Now we will measure relative risk. Relative risk is the strength of association. Incidence among exposed and incidence among non-exposed. We will divide them. Incidence among exposed was 28 and incidence among non-exposed was 17. So our answer will be 1.5. Roughly it is 1.5. So we can say that relative risk is greater than 1. So there is positive association. You must interpret according to relative risk. Remember, if relative risk is greater than 1, there is positive association. If relative risk is equal to 1, there is no association. If relative risk is lesser than 1, there is negative association. Now, we'll calculate attributable risk. How we'll calculate attributable risk? Remember the formula, incidence among exposed minus incidence among non-exposed. Incidence among exposed was 28. Incidence among non-exposed was 17. And divide it with incidence among exposed and multiply it with 100. So you must remember the formula of attributable risk. We subtract incidence among exposed with incidence among non-exposed. Divide it with incidence among exposed and multiply it with 100. So our answer will be, we'll divide 1100 with 28. So our answer is 39%. This means that in our study, 39% of heart disease is caused by smoking. So we will interpret this that 39% of coronary heart disease in our study is caused by smoking. So there is positive association. We have calculated incidence. Incidence among exposed was greater than incidence among non-exposed. We calculated relative risk. It was greater than 1. We calculated attributable risk. It was greater than 0. So there was positive association in our study. We will summarize the session. We have discussed difference between case control study and cohort study. You have to remember few differences like case control study is a retrospective study. Cohort study is a prospective study. Case control study is done for rare diseases. Case control study is inexpensive. Cohort study is expensive. Case control study takes lesser time. Cohort study takes time. Bias is a problem in case control study, or bias may arise in case control study. Attrition problem arise in cohort study cause there is loss of follow-up. People can migrate, they can die, and we can find odds ratio in case control study. We can find incidence. We can find relative risk. We can find attributable risk in cohort study. So this is the common university question that differentiate between case control study and cohort study. Then we have discussed few numericals, how we will pick or how we will identify that this study is case control study or cohort study. When number of diseased people is greater than exposed people, this is case control study. Cause in case control study, we divide diseased into exposed and non-exposed. Like we can write this, we can divide the case and divide the control into exposed and non-exposed. So number of cases is greater than exposed. This is the identification point. And this is retrospective study. And in cohort study, we divide exposed people into diseased and non-diseased cause we move from exposure to outcome. Like we can say that we take people who are exposed, exposure and non-exposure. We divide them into diseased and non-diseased. So number of exposed people is greater in cohort study. This is cohort study. And number of diseased people is greater in case control study. You have to identify whether this is case control study and cohort study. Plus, we can measure exposure rate and odds ratio in case control study. It can't measure incidence. This is an MCQ. Incidence is measured in cohort study. And in cohort study, we can measure incidence. When we can measure incidence, we can measure relative risk. Then we can measure attributive risk. This is common university question that what is measure of risk in case control study? Always remember. Odds ratio is measure of risk in case control study. In cohort study, when they say measure relative risk, you have to measure incidence. Then you will measure relative risk. Then you will measure attributable risk. Then how will you interpret? Let's suppose odds ratio is 2 in case control study. This means that exposed people had 2 times greater risk of developing disease. In cohort study, how will you interpret? You will interpret from relative risk. If it is greater than 1, let's suppose it is 3. This means that there is positive association. If it is 1, there is no association cause incidence among exposed and incidence among non-exposed is equal. When incidence among exposed and non-exposed is equal, there is no significance. Then attributable risk or specificity or specific risk factor. This is also an MCQ. So this was all.